In this video tutorial, Simulink will be explained. The objective here is to demonstrate how Simulink can be used to design, test, and analyze simple electrical systems. Simulink is a companion program to MATLAB, which is used for modeling, simulating, and analyzing dynamic systems. Simulink has two windows. The library window, which contains several libraries. Each library contains blocks. The other window is the workspace window, and in this window the Simulink model is constructed. We will apply Simulink to solve differential equations. As an example, consider an electrical system which is modeled by the differential equation here. X of t is the input to the system, y of t is the output of the system. X of t here is a unit step function, and the system has initial condition. Solving the differential equation analytically gives us the output. The differential equation model can be replaced with the system model here, which is made of an adder, an integrator, and a scalar. Now let us see how we can model the system using Simulink. To create a system model within MATLAB, we need to launch the Simulink application. So we come here to this icon Simulink, select it, and we get the Simulink library browser. The Simulink browser contains many libraries in different areas of science and engineering. For example, for electrical engineering applications, the communication systems library would be very useful. We also have control systems library and so on. For most general purpose applications, the Simulink library would be used. If we open this library, we can see we have several sub-libraries. The ones we'll be using in our project would be the commonly used library. We also have the sinks library and the sources library. In the commonly used blocks, we'll be using blocks like the integrator, the sum block, and others. And for the sinks, we'll be using the scope block, and for the sources, we'll be using the unit step block. Now let's create our system model based on the first order differential equation explained before. And to do this, we need to create a new workspace by coming to this icon here. This workspace can be used to build our system model. So the next step is to drag and drop our blocks into this workspace. So for example, from within the commonly used blocks, we need the integrator block, so we'll just drag it and drop it in the workspace, and we repeat this with the other required blocks. Once we have all the blocks needed to build the system, we need to connect them. Connection is very easy. For example, we come to the integrator, click on it, and then drag into the gain block. Once the system has been interconnected, we need to update some of the parameters within each block. For example, the integrator block, we need to add the initial condition. We double click on the integrator, so we get the function block parameters for the integrator. So we come to the initial conditions area field, and we change we add the initial condition, in this case -2. In addition, we need to change the gain of the gain block, so double click, add the gain, in this case it's -5. Now we need to run the system model and observe the output, but first we need to open the oscilloscope, so double click on the oscilloscope and we get the oscilloscope screen, and now we can execute and run the system model. So we come to this play button here, we click on it, and we get the output of the system. Now the next step is to analyze the output and try to get some useful information about the system. So you can see the response of the system is divided into two areas. From 0 to 2 seconds, the system is nonlinear and unstable. This is called the transient state, while the system from t greater than 2 seconds is linear and stable, and this is called the steady state response of the system. This concludes this video tutorial.